Good morning, and today we are working on Chapter 10 and we're working on the practice test. So it's asking us to do a stem and leaf plot of the data. And basically all this is a way to just plug in data. So we have the number here in the tens and we have the number in the ones. And rather than writing all those numbers down so it's difficult to see, we just organize them. So this is going to be all the tens and these are going to be all the ones. So if it is a 20, it's going to have a 2 in the tens in the stem and a 0 in the leaf. Okay, so we're going to plug in our numbers and we see the number 20, and here's 20, and then we see the number 21, we see the number 26, here's our 6, so we look for 6, here it is, and then we see 27 and 29. So now we do the same thing with the 30s. We find a 31 right here, and we find a 38. Well, there's another 30 up here that we haven't plotted yet. That's the number that goes right here. Find that number, and that's your answer. If you said 6, you are correct. So now we have a stem and leaf plot that shows the heights in meters of several redwood trees. How many of them are less than 30 meters? Okay, so the stem and leaf plot shows the height in meter of several redwood trees. How many of the heights are less than 30? So now we're going to look at this, and here is our 0. So these are going to be 5 feet, 5 feet, 6 feet, 7 feet. This is going to be 1, and 0 is going to be 10, 10. And again, it says 1 and 0 equals 10 meters. So these are all less than 30. These are all less than 30. So all we have to do is count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we find that there are 15 trees whose heights are less than 30 meters. Okay, this frequency log shows the number of books read by students in class over summer vacation. Display the data in an interactive histogram below. So we have number of books, number of students who read 0 to 1 books is 5, number of students that read 2 to 3 is 8, 4 to 5 is 4, and 6 to 7 is 3. So on this side right here, we have our frequency, and on the bottom, we have our books. And we just plug them in, and there you go. You just drag it up. The histogram shows the length in centimeters of several fish. How many of the lengths are at least 20 centimeters? It's one of those with big ideas that I'm not always crazy about the question. So here it is. They have 5 here. So this is going to be oh, I'm so sorry. I did it wrong. I was looking at it backwards. Sorry. At least 20. I was thinking 20 or less. Okay, so at least 20 is going to be 7 plus our 4. Big ideas, you rock. Miss Adams is wrong. So we're going to add the 7 plus the 4, and we're going to get to 11. This is daily text read, and they wanted us to describe the shape of the distribution. And so when we look at this, it goes mostly, okay, here's our median. It's going to go mostly to the left. It's skewed left. Describe the shape of this distribution. When I look at it, it's almost like a mirror image of it. So I would say it's symmetrical. Okay, exercise 7. Use the number line below to identify the least value, first quartile, medium, and third quartile, and the greatest value. Okay, so the least value of our numbers is going to be the number 11. The greatest value is going to be our 26. That's going to be our biggest or our greatest. And then we want to know what is the median. Well, we have to plug these numbers in on a number line to find them. We need to go in order from 11 all the way up to 26. And when we do that, we plug them all in, we find out that our median is 19. In order to find out our first quartile, we take the 11 and the 19 and we find the difference. And we find that the first quartile is going to be for 14. And then we do the same thing. We take our average of our 19 and our 26, and our quartile right here is going to be 22. Here's the answer to exercise 8. Fox and whisker plot shows the weights in grams of several crystals. Are the data more spread out below the first quartile or above the third quartile? So again, here's our least number, here's our greatest number, here's our median number. This right here represents our lowest or our first quartile. This represents our third quartile. This is our box, and this is our whiskers, these little extensions out here. So is the data more spread out? Well, if we look here, look at how long that whisker is, and look at how long this whisker is. So it's spread out more here than it is here. So it's below the first quartile. The double box and whisker plot represent the daily temperatures in degrees for several days in two cities. So when we're looking at city A and we're looking at city B, city A, the temperature ranges from 64 degrees all the way up to 75. Well, city B, the temperature ranges from 68 to 76. So which one is more spread out? Well, A is much longer, it's much more spread out than B is. Okay, so now this stem and leaf plot shows the heights of people in line for an amusement park, which is not true. It's a little bugger because then you got to kind of go through each of them. But we're going to start with the first one. So the first one says this. The first one says the median height is 68 inches. Well, if we can prove that one wrong, then we don't have to do any further. Okay, so remember, we're going to count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we start from this end, we should go up to the sixth one. If we start from this one, we should go up to the sixth one. So 1, 2, 3, 4, 5, 6. So it would be 67. 1, 2, 3, 4, 5, 6. And we land both on the number 6, or the sixth number in, because 11 divided, if you have 11, you would have 5 on one side, 5 on the other side, and 6 would be the middle number. So 5 plus 5 is 10, plus that one middle number would be your 11th number. So then answer here, it would be the middle number, or the median number would be 67 inches, but they give us an answer of 68 inches, so that is incorrect. So the first one here is incorrect, which is the median height is not 68 inches, so that's our answer. Okay, so the histogram has the number of students and the frequency. How many classes have more than 20 and less than 27? So we can't include this group right here. So it has to be this group right here and this group right here, because these are more than 20, but the numbers are less than 27. So we have 4, and then we have 3. So 4 plus 3 is going to give us 7. So this problem is a little bit trickier, because what they're asking us is they're asking us a percent, but what they've given us is they've given us frequency and the number of boxes. So what we have to do is figure out how many boxes there are total, then find out what the percentage is. So right here I've got 3 plus 4 is 7, plus 6, 7 plus 6 is 13, plus 7 is going to give us 20, plus 5 is going to give us 25. So now we have 25 total, and we have 7 and 5 is 12. So now we have our fraction. Our fraction is 25 total boxes, and we have 12 that were less than 10. So how do we get from 25 to make this into a percentage to 100? Well, we multiply this by 4, and then we're going to multiply this by 4. 4 times 12 is going to give us 48. And the way we make 48% is it's 48 out of 100, which is what percent means. 48 out of 100 equals 48%. And before I even plot this, I can look at this, and it wants to know what is the shape of the distribution. Well, if you think of something symmetrical, if you think of something like a bar graph, if you think of the 5 being the tallest, and then the 3 coming down, and then the 1 coming down, there's a 1 here, a 1 here, a 3 here, a 3 here, and a 5 in the middle. So it's going to be symmetrical. It's almost like if you took a piece of paper and you cut 1 inch and then 3 inches and then 5 inches on both sides, you could fold it in half. So of course it's going to be symmetrical. The distribution is symmetrical. This is one of those where they want you to compare Class A and Class B, and they want to know which one is taller kids. Well, this is one where you could just kind of move the blocks over. You can move where you have up to 6 over here. You can move that down 2 and make that equal to over here, and then just keep plotting along until you find your answer. Or you can add up the totals over here. You got 2 plus 4 plus 6 plus 7, and add those up, and then add these up and see what you come out with. The dot plot shows the number of magazine subscriptions for several people. What is the most appropriate measure to describe the center? When you look at this, you can see it's fairly symmetrical. Like you could just fold this in half right here, and it would be the same on this side as it is on that side. So it's symmetrical. And the way you would find that is the mean. The mean would be, you could take all the average of all of these numbers and plug it right in, and your mean would be the most appropriate way to measure the center. This dot plot shows the weight in pounds of several packages. What is the most appropriate measure to describe the variation? So remember, variation is always variety. How is things changing? But the first thing is the distribution is symmetrical. You can see that it's just completely on both sides. And what is the most appropriate measure to describe the variation? The second answer you do not need to know, so I'm just going to tell you what it is. It's called MAD, M-A-D, mean. They want to know what is the distribution, how is it distributed. If you look at it, it's skewed mainly to the left. So the blank is the most appropriate measure to describe the center, and that's going to be the median. So you're going to put all the numbers listed together, and then you're going to find the middle number. Histogram shows the daily temperature in degrees Fahrenheit for several days in a city. What is the most appropriate measure to describe the variation? And we can see that it is skewed to the left again. And then the most appropriate measure, and you can kind of see like that little slope. What is the appropriate measure? And I'm going to just give you the answer. It's IQR. Don't need to know it for today. Just write IQR in your answer. Which store has prices with a symmetric distribution? If you look right here, you can almost cut this in half. That would be symmetrical. This is way not symmetrical. So store A would be your answer. Whew, we did it, guys.